Thank you for joining this lesson. We're going to discuss cubic curves and cubic equations number 24. We are told in the first place to fill the table below for the function y equals to x cubed plus 4 squared minus x minus 6 for the range of x between -5 and +3. The table has already been outlined. We have from -5 the values of x running all the way to +3. Then the values of y now, which are obtained by substituting the respective or the corresponding values of x in the function so that we may get the y's. And I'm going to do that for all the values, including the provided one, just to confirm and to show you how we are going about it. Remember to subscribe to this channel and to share our links with friends. So when we begin, we're supposed to take we open brackets -5, then we cube plus 4, we open brackets again, -5, we square it, then we subtract, you open brackets -5, then we minus 6. This is giving us exactly -26. So what we are supposed to do, so this value has been correctly inserted there. What you're supposed to do is, where we have x is where we are substituting the value in the space here. Now I go again to the equation and I open brackets -4 cubed plus 4 into -4 squared minus -4, then I subtract 6. This is giving me exactly -2. -2. We go to the next, which is a -3. So I'll begin with -3 cubed, then plus 4 into -3 squared, then minus a -3, then minus 6. This is going to give us +6. The next, open brackets -2 cubed plus 4 into -2 squared minus a -2, then minus 6. This is giving us 4. I hope my accuracy is not misleading anyone. My speed, -1 power 3 plus 4 into -1 squared minus a -1, then minus 6. This is going to give me -2. Then when we substitute 0 in this equation, this becomes 0, this becomes 0, this becomes 0. We remain with a -6. So when x is 0, the value of y will be -6. We can go next to +1. So 1 cubed plus 1 cubed plus 4 times 1 minus 1, then minus 6. This is giving me -2. That gives me -2. We can go to where 2 is. So we substitute 2 now in this case. We begin with 2 power 3 plus 4 into 2 squared minus 2 minus 6. This is giving us 16. And finally we have a +3. So 3 power 3 plus 4 into 3 squared minus 3 minus 6. This gives me +54. +54. So these are the values now of y with the corresponding values of x. We are told in the second part, on the grid provided, draw the graph of y equals to x cubed plus 4x squared minus x minus 6, for x ranging between -5 and +3. Let the scale, use the scale of 1 centimeter to represent 1 unit horizontally and 1 centimeter to represent 10 units vertically. Now that the scale has been chosen, our work has become easier. Our work becomes easier. For the vertical axis, let me begin from here. This is the vertical axis, and now I can stand here and get what we call the horizontal axis. This is the horizontal axis. Now we are told the scale for the horizontal axis is 1 centimeter for 1 unit. So 1, 2, 3, 4. Then this is -1, -2, -3, -4, -5, -6, and such. That is the horizontal axis scale. Now for the y-axis, we've been told for every 1 centimeter we have 10 units vertically. So from 0 we should go to 10, 20, this is 30, 40, 50, 60, and such. And here we will have -10, -20, -30, and such a trend. So now we are having the axis here. The next thing is to plot the coordinates. We have the first one. I'm going to read the coordinates. They are as just we have fixed them in the table. -5, -26. -5, -26. So if this is -20, it means for every small square we have 2 units. So 26 is going to be at this point. Allow me use a different ink for the coordinates. So we're going to have it here. Going to have the coordinate there. Then the next is going to be -4, -2. So -4, -2. So -2 is just one small square. One small square becomes -2. So -4, -2 is just below 4 there. That is where the coordinate is. The next is -3, +6. -3 and +6. +6 means 2 small squares just here. Yeah, that is +6. The next is -2 and +4. -2, +4. The point will be here. Then from there we go to -1, -2. -1, -2. -2 means just here. Yes, a small square below -1. That is the point. The next is 0, -6. 0, -6. So -6 is a point here. After 3 small squares, we go to -6. The other one is 1, -2. 1, -2, which means here. The point is there. The other one is 2, +16. So 2 and 16. 16 must be after 10 we go 3 complete squares, small square that is. This is going to be our 16. It should be 216, sorry, 216. The coordinate should be here. Then finally we got 354. 3 goes with 54. So after 50, 52, 54 should be here. 354. You're supposed to ignore this dot. You're supposed to ignore this dot. Yeah, so that is how the coordinates are on the Cartesian plane. That means when I connect these coordinates using a smooth curve, I will get my graph. So let me connect them. From this, I will go smoothly. There. Then from this point, I'll go down. Then I turn again. Yes. So this is now the curve, which is cubic. The curve y equals to x power 3 plus 4 x squared minus x minus 6. So this is the cubic curve. That is the cubic curve with 2 turning points. The next question now is telling us to use the graph to solve the following. The first equation is x cubed plus 4x squared minus x minus 6 equals to 0. For us to solve these equations, we must subtract them from the original equation. Original equation is y equals to x power 3 plus 4x squared minus x minus 6. So now we arrange this equation with corresponding terms such that 0 comes to this point. Then we begin with x power 3, 4x squared minus x minus 6. Now we subtract downwards. We're going to have y equals to, this one cancels, this one cancels, this one cancels, this one cancels, and we're going to find, when you subtract the two, it's y equals to 0. Now, which line is this? This line is the x axis. The line which is equivalent to the resulting line here is the x axis. Now we want to see where the x axis is cutting this line. Where the graph is cut by the x axis will give us the values of y. Where this line cuts the graph, where that line cuts the graph, and those points are going to be, we're going to read them. This is negative 3.8, negative 1.4, and I'm also having positive 1.2. So the values are going to be negative 3.8. The values are supposed to be 3 because it is a cubic curve. Negative 3.8. X is also equivalent to negative 1.4. And x is also equivalent to positive 1.2. So these are the three values for the equation here. We subtract it from the original equation. The resulting line, we check now where that line cuts the curve. And that line, which is the x-axis, cuts the curve at these points. We will do the same for the second. We will take the original equation, y equals to x power 3 plus 4x squared minus x minus 6. Now I subtract this from, this will be 0. Then I will be having at this point, when I observe at this equation, something is common. 3 can be factored out to remain with 3x plus 4x squared minus, when you factor out 3, I'm going to have 5x minus 7, then equals to 0. So this 3 can cancel with 0, and now the equation becomes this. So I've simplified this one because 3 is common. When we factor out this 3 now, we're going to have the equation becoming x power 3, x power 3 plus 4x squared minus 5x minus 7. Now that is how the second equation becomes after simplifying it. This means now when we subtract, I'm going to have 0 equivalent to this cancels, this also cancels, but when you get to this term, negative x, remember we are subtracting, negative x minus negative 5 becomes negative x plus 5, making it 4x minus 6 minus negative 7, it becomes negative 6 plus 7, which is 1. So now this is the equation which will be used to determine the roots of this other equation. So this line now, we plot this line now with values of x and y. So we're going to plot it. We can begin with when x is 0. We go to when x is something like even 2, even 4. Those are enough. So when x is 0, the value of y will be 1. When x is 2, the value of y becomes 9, because this will be 8. When x is 4, this becomes 16. Then plus 1, 17. And many other values which we can come up with, like 25, like 20 and 1, so 21. Yeah, such things. So now we can plot the line obtained here. We can plot it on the same axis. On the same axis. So 2, 9. 2 goes against 9. 9 is somewhere below 10. 2, 9. Then we also have 4, 17. 4 goes with the... Okay, 4 will be outside the range of values. So we can work with values which are smaller than 3 now. Which are smaller than 3. And we would say for the same, if we check 3, you realize when x is 3, this becomes 12 plus 1, 13. When x is a value like, we can go with 1. We're going to have 4 times 1, then plus 1, it becomes 5. So we can go with 3, 13. So 3, 13. 3, 13. Just above 10, this will be 12, 14. So 13 is somewhere here. 13 is somewhere here. At x equals to 0, we said y is 1. X equals to 0, the value of y will be 1. So 1 is somewhere there. That is where 1 is. When x is something, like negative 2. When x is negative 2, for this case, negative 2, the value of y is going to be, now we substitute negative 2 in this equation, negative 8 plus 1. So when the value of x is negative 2, we're going to have negative 8 plus 1, you get 7. So let me now plot those values. Let me plot those values. So I'm going to have all these values connected. Yeah, I think 3 values are enough. So when I connect them, I'll get my line. This is line y equals to 4x plus 1. 4x plus 1. 4x plus 1. Now that we have plotted the line, we are going to look at the points where the line cuts the graph. The first point is here. And the value of x at this point is going to be negative 4.8. Negative 4.8. x equals to negative 4.8. X is also equal to, at this point, I think this is just before 1. This is going to be 0.8, which is negative 0.8. And finally, the value of x is going to be, the value of x at this point is going to be just after 1, but before 2, 1.6 positive. 1.6. So the values of x, which are the roots of the second equation here, are as shown there. Those are the 3 roots. For the first equation, we said they are here. So we are saying basically for this one, you take the original equation and you subtract the original equations. Original equation, the provided equation, you subtract. The line you will get, because the subtraction reduces the lines, the subtraction reduces the equations into straight lines. So the straight line you are getting now, you relate it with the curve. Where it cuts the curve, those becomes the roots. In the second one, we have also done the same. Original equation, the provided equation. When you subtract, the 2 equations of curves are reduced into a linear equation. We plot the linear equation. Where that line cuts the graph, we obtain the roots of x.